All right, PF1 video, wow, 14. So it'll be kind of a short day today would be my guess. We need to talk about problems 12, and there's a little problem 13 attached to that if I remember correctly, which we haven't formally given you yet on Lab 4. We'll update the HTML for that then and assign one more problem, or again, I think the second problem is just print the results from the first one. I ought to just roll that together. Maybe I have. I'll have to look and see. But anyway, we got just a little bit more to cover on Lab 4. And I did see a number of students were working on Lab 4 over the weekend. I did get 2 questions on it even then, so that's good. You guys make a good progress on Lab 4. I see a number of students nodding at that. So with a little luck, should be a review, of course, you know, the things we've covered in class and so on. But continue to send questions or stop by again. We'll finish up a little early today, so you'll have time to ask questions if you have them on Lab 4. And the other thing, in addition to spending a bit of time here on Lab 4, today is going to be to get you guys ready for our midterm exam, just kind of let you know what to expect there. And when we went over the syllabus, oh man, that's a long, boring day as it is. So by the time we got to the end and we're looking at homework policy and late work policy and those kind of things, there's also a testing policy, which I have on my home page there, which is, all right. So there's also a testing policy or test policy. I might have clicked on it, might not. But anyway, we'll look at that a little bit then also to get ready for our exam. And so to be clear, the midterm exam will be the Monday that we return then from our break. So welcome back, I guess. You know, I've asked students in the past if they would rather have the midterm exam right before or right after the break, fall break, spring break, whatever, you know. And they've kind of universally chosen to have it afterwards, because the assumption is you guys are probably taking final exams this week for your 8-week courses then. So anyway, so that we don't conflict with those, we'll put it off until right when we return from our break then. So welcome back, I guess. And the testing format's kind of evolved a little bit over time. You know, the truth is, in the PF1 midterm, we haven't done a lot of programming just yet because, well, when you look back on the schedule, well, good heavens, this is week 8. So out of the 8 weeks, we spent the first 2 weeks basically just learning the development environment, and then kind of slowly got off and going and so on, and covered a little bit more, every day, of course. So I think at this point we've covered given you a good introduction on programming. We haven't done a whole lot, but, well, you know, that said, we will have completed 4 programming labs, and so that's something. And anyway, but in the past, one thing I did also just to, for the heck of it, I guess, is I would sometimes throw in some questions just right off the notes. You know, like imagine studying for a test in a history class or art appreciation class or wherever it is. We've all taken plenty of classes, of course, where you come to class, you write down notes, you memorize the notes, you come back and regurgitate them then on the test. So I've given some questions that are right off the notes. And it could be, you know, definitions and rules and pro tips, or, you know, Java history, or any number of different things like that. And so I've given some questions like that. But what I've kind of come to realize is sometimes I would have students that are good programmers, but they forgot to study that stuff and ended up doing a little worse than what they would otherwise have done if I had just given a programming test. And so kind of with that in mind, I've kind of here lately scaled that stuff back. So I'm going to say that our test is going to focus on programming, okay? And so related to that, and again, part of this is going to be, we're going to go over these rules one by one here, but just what to expect. I'm going to issue you guys a new login, a second username that you're going to log in. And it's going to be based on whatever your normal login is, but I'm just going to stick the number 2 on the end. So if your name is Bob Smith, and so as a result your username is Bob S., well, then you would come in and you'd log in as Bob S. with the number 2 tacked onto the end. So that would be your username. And your password will be the same password that you use on your normal account then, all right? And so, and again, this will be covered on our rules here. So while we're taking the test, you can only use that new account that I issue you for the purpose of taking the test, okay? And part of it's going to make it kind of easy for you in terms of, in the past, I actually have had you put your work maybe underneath your PF1 directory. You might create another directory called testing or midterm or something else like that and stick your work down there. But anyway, what we're going to do for the for the midterm exam and all the exams to follow, I'll give you a new account. And if I give you a, which is likely that I will, if I give you a starting point for the program, then it will be in the home directory of that new account. So you won't have to go looking for it under a PF1 directory or a midterm directory or whatever. All of your work will be right there in the home directory of your new account. And one other thing related to that, hey, well, if you're logging into this new account, well, what about having access to, what will we have access to in terms of our old account? And so what I normally do is I will provide access to some of, and every once in a while, in fact, all of your README files. All right, your README files that I complete for you when you finish up a lab and I grade it and so on. You know, I'll put a readme.mcu file there in your lab directory. And anyway, so best case, I guess, I might copy all of those README files to the home directory of your new account. And they'll just be readme.lab1, readme.lab2, and so on. And so, you know, depending on circumstances, I might provide all of those. But also there have been situations where I want to give a programming problem that's pretty doggone close to one of your labs. It's pretty close to one of your labs. And that's kind of a good situation for you, I guess, you know, and that it's that much more similar to something that you've already done. But, well, what I will do sometimes then, if I give you a problem that is real similar to a lab, and that's kind of to reward the students that did their own work on the labs and were able to complete it on their own and now know that work and should be able to demonstrate it again, you know, on the exam. But anyway, so if I give a problem that's real similar to the labs, it is often the case that if it's, depending on how similar, I might not provide access to that particular lab's README file then. So again, when you log in to your new account, you will have access to, quote, some of your README files. And certainly, you know, like I would not expect you to, we've been real clear about this from the get-go, and we've demonstrated it a number of times in class. I don't expect you to have memorized everything that's necessary to make an interactive program. Oh, your import statement, your throws IO exception statement, and even worse than that is that big long variable declaration where we declare our buffered reader variable and so on. So if your program is interactive, I'll probably give you access to your lab 1 or your lab 2 that were interactive then also, so at least you have an example of those. But anyway, just because it's so boring, and we'll get this out of the way here before we move on to the new material, and I'm here. Let's go and just look through our testing rules here then real quick. All right. So start up here at the first, you know, kind of like is often the case when you're taking an exam. We're going to have you either leave, you know, in your bag or leave at home or whatever, your books, notes, phones, other resources, and so on. It is a closed book, closed note exam. So remove those items from your desktop then when you sit down to take your exam. And, well, you actually can print things straight from the server, but I've not bothered to show you how, so without copying and pasting to something else or whatever, you know. In fact, we'll just state for the record that that's going to be prohibited, and also we're not going to, and again, you can send files from the server to somewhere else through email also, but we haven't bothered to show you how to do that. But anyway, don't make any copies of the exam or your solutions to the exam. And, you know, it's not as much in PF1 as it will be certainly so in PF2 and 3, where you have some logic problems to solve to figure out the best approach to tackle a particular problem. And we will, as time goes on, you know, stress the importance of writing down some notes and collecting our thoughts and summarizing and drawing pictures of the data and looking at it and thinking about how we might tackle this problem and so on. So any kind of notes, design work, pseudocode sketches, or whatever that you want to write, you'll just write on the back of the test. The test will be at least 2 pages, because page 1 of the test literally is all of these rules, and then a place that you signed at the bottom that says, I'm familiar with the rules, all right? So page 1 is just the rules. Page 2 would be, you know, the first problem or 2 then on the exam. So you'll have at least 2 pages, and the back of both of those will be blank, so you can do all of your sketches and doodling and everything else there then. Yeah, this is kind of a biggie. Again, I'm glad that we have time to go and talk about these things. You know, many students, some students at least, will prefer to work during class using their own notebook or whatever, which is perfectly fine. But on test day, you're using the computers that are supplied here by the CIS department then. So that's a bit of an assignment for you today then, in fact. Make sure if you're in the habit of using your own Mac or Linux laptop or Windows laptop or whatever, make sure that you have PuTTY installed on the desktop computer. I think it's the case on all of them. Anyway, make sure you have access to it. Make sure you can log in from the seat that you're used to sitting in, because you don't want to come in on test day. I mean, you're already stressed enough on test day. You know how that is. If you came in and discovered that you couldn't log in, that would be kind of a pain, and it would set you back in terms of time also to get that issue resolved then. And that's another issue also. Sometimes in PuTTY, you know, I have in my configuration here, my session I have saved, it just saves the host name and the colors and the fonts and all the rest of that. Sometimes students will also have it save their username, maybe even also their password. And if you set up your username and password in PuTTY on week 1 and you come back after spring break then, which is essentially week 10 then of as far as how long it's been, you might have forgotten your password. So make sure you can log in, and again, make sure you can log in from the PC that we provide here for you in the classroom. And oh yeah, so we talked about making copies of your test questions or solutions or whatever, and well, you can't print them, but well, what about copying and pasting them somewhere else? Well, here's the answer to that. On test day, the only program that you can run is PuTTY. So no Word, certainly no web browsers, anything else like that then, so just PuTTY. This isn't much of an issue here, but anyway, do all your work in the specified directory. Again, not much of an issue now that we're giving you accounts and having you do your work just in that home directory. You know, it is a test. Keep your eyes on your own screen, papers, or whatever. And here's kind of a new-ish one, and it's kind of funny. I mentioned this when we went over the syllabus, if I remember correctly, that lots of, quote, dumb rules that I chuckle at when I just even look at the darn things are there because of some situation that me or some other instructor or whatever has hit on before. So as a result of some knucklehead student, it's almost always a guy, it seems like, but because of some knucklehead student, we have to have this goofy rule. And this one just popped up a few years ago. I did have a couple of students that were getting up and going back and forth and spending lots of time in the bathroom for reasons unknown, and I suspect there might have been some weird stuff going on there. So if the old guy in the front of the room, or actually on test day in the back of the room, can go for an hour and a half without taking a bathroom break, then we're going to assume that you young folks can do the same thing. So make sure and take a pit stop on your way to class, because the rule at least is you're not going to leave the room during the exam. Hey, we're getting closer to the end now. So a lot of times I'll give you a starting point for a problem. Not always. You just read the instructions, and that's not part of these rules here. But in terms of testing suggestions, testing strategies, read the description of what you're supposed to do, and not just skim through it. That's kind of a problem that students will make sometimes, especially students that have a little more experience or whatever. They're just used to skimming through. Oh yeah, got it, and they set the test aside and they just go to work. But sometimes they'll skip little details or whatever. They're just kind of, they're intending to just kind of speed read through there to get the gist of what I want, and then they want to write code, and anyway, they can make mistakes there. But anyway, read the directions very thoroughly, and also, if I say note this or a simplifying assumption or something else like that, make sure and read those also and think about them when you're considering the problem. Because any little notes or suggestions, or again, sometimes I'll word it as simplifying assumptions, a lot of times they end up, if you understand what I'm trying to tell you there, you recognize, oh yeah, because of this thing here, the job I have is a little bit easier than it might otherwise be. So make sure, just read everything thoroughly. But if I give you the instructions will either say, write a program to do X, or more often than not, it'll say, in your directory, you will find a file named prob1.java. Modify that program so that it does X, Y, or Z, something like that. Okay, so read. Sometimes it will just say write a program. Otherwise, it will tell you to modify or finish a program. But anyway, if I give you any code, don't modify my code except as instructed. Not too much of an issue on test 1 and PF1. But a little later on, it can be the case where a student can write some code and it doesn't quite work with my code, and they want to modify mine instead of theirs. But also not a big deal for PF1, but we'll go ahead and talk about it now just to be clear, is if there are methods, or methods. What the heck are methods? Well, print line is a method, parseInt is a method, read line is a method. There's any number of methods that we're using that are kind of built into the Java programming language and so on. And if a particular problem, not much of an issue for this particular test, but as we go forward, it can be the case that, oh yeah, maybe the Java language has some tool here that the old guy hadn't talked about, but it'll help me out in this particular case. Well, this rule addresses that. Don't use methods or functions or techniques that we've not covered in class. If you're not sure, you're certainly welcome to stick a hand up and ask me for clarification on that on test day. And if the test provides some sample data, now it can be the case that your programs might be interactive, and by the time we get to the final exam, also we'll show you how to write programs that can read data on the command line. So there's a number of different ways that we can get data to your program. And anyway, if the test does provide some sample data and some sample output, well, okay, that's all well and good, but your program should work for other data as well, which seems to be kind of a common sense, but still I put it in there just for clarity then. And oh yeah, here's one again. We've kind of hit on this just a minute ago. If you're issued a new login for the purpose of taking the test, and you will be issued a login for the purpose of taking the test, you're prohibited from logging in using your normal login. All right. So questions on those? Not too big of a deal. All right, so there's that. We got that boring work out of the way then. So we'll close that up and move on to our lab then. So, okay, let me go ahead and pull up the assignment, and then I'm going to go ahead and update the HTML and bring in problem 12. I'm trying to remember if I still have a problem 13, which is just printing the results from 12, or if I finally just updated it, where problem 12 says do some calculations and print the results. So this is lab 4. Okay, so currently, oops, that says PF2. Let's make that a 1. All right, so currently, yeah, we tap out at problem number 11. Okay, so to the rescue here, let me public HTML PF1 lab 4. All right, so let me copy full to index.html. Okay, so I've overwritten this slightly smaller version of this file with a little bit bigger version of the file, and now when we hit F5 to update, okay, 12, oh that's right, 13 is a different problem, but it's no big deal. So tell you what, let's do here, let's go ahead. So 12 and 13 are the new problems. We'll talk about them in reverse order, if you will. Problem 13, really kind of trivial. Rewrite this piece of code here, which has a for loop, and rewrite it as a while loop. So that's really trivial. You remember in our notes, we introduced while loops first, and then we showed you, oh yeah, a for loop just takes some very common components that we can often build into a while loop, and it just sneaks them all into one line of code. We've got our initializer, our loop entry condition, and our updater all in one place here in the for loop. But those need to get kind of moved into the appropriate location then to rewrite this for loop as a while loop. We can always rewrite a while loop as a for loop and a for loop for a while loop. They are 100% interchangeable. But just like we said in class in the last lesson, we're going to tend to use a for loop to count and a while loop if we're just waiting for something to happen. All right. So anyway, so there's that. So let's look at number 12. Let's have you guys read through here then, and then we'll start talking about it. This is a good little problem. This is a good problem here. And this is kind of sticking our toe in the water, kind of kicking the tires, I guess, on a typical PF2 kind of a problem. So it's kind of like a PF2 problem, where we have some data in an array, and we ask you to find something, do something, or whatever, somehow manipulate that data, you know. And at the end of the day, usually it takes a loop, maybe two, an if statement or two, something like that. It ends up to be not too big of a deal, but it's a pretty good little challenge. Well, until you've done it a time or two, and then it's no big deal. Then it's just one of the little tools in your tool belt there, you know. But the first time, it can be kind of tough. So we're we're going to squeeze that in here to lab 4 and PF1. But trust me on this, this particular problem is going to come back and it's going to help us, assuming we understand it, or hurt us if we didn't understand it, in PF2. Because our very first lab in PF2 will involve some logic that is real similar to this. So I know it's the case that we have a few students that you're taking PF1, but you are not going to need to take PF2 depending on your degree. And so for you guys, no big deal. But certainly if you're planning to come back and take PF2, I'm asking you to do yourself a favor and give us your best effort on this and do your own solution and understand it thoroughly and so on. This is not one that you want to, Google or type into ChatGPT or whatever. You want to learn how to do this on your own, because this is a sample skill that you're going to need to do things similar to in PF2. We're going to kind of move away from arrays a little bit after our midterm exam here, but again, they're going to come back with a vengeance then in PF2. So finding the largest element in an array. In other words, finding the largest number in a list of numbers. And just like many problems that we can give you in PF2, it's a simple thing to describe and it's a trivial problem to solve in the real world, but writing a program to do it, kind of tricky. So let me get my little drawing tool out here real quick. All right, PF1. And we'll go here. And this is, often the case in PF2 that I can give you a description for a program I want you to write. And the description is 1 or 2 sentences. And as a intelligent person, you could understand what I'm telling you and you could do it and it would be trivial. But again, for a new programmer, it can be challenging. All right. And especially if the amount of data is fairly small. So let's see here. Let's say that I had, 5 and 2 and 7 and 3 and 4. All right. So there's a, quote, list of numbers. We could talk about putting them into an array, or for right now, we're just as people just looking at a list of numbers. And this is one of those situations where the problem is so easy that I just tell you, hey, everybody, find the largest number in the list. And everybody casts their eyes upon the screen. You just glance at it, and the answer pops into your head. All right? And it helps that it's such a small little list, of course, But if I asked you, hey, well, we need to break down the process that you used to solve this little problem, but the solution came to you so easily, so naturally, that if I asked you to describe in detail exactly what you did, the honest truth is, I looked at the screen, the answer popped into my head, and I'm done, But that's thanks to the brain that God gave us, and we're able to do simple things like that. But anyway, writing a program to do it is more challenging. And so one thing that you can do sometimes to kind of help you think in the right direction is, well, if the list had more than 5 elements, then maybe it wouldn't be quite so easy for us just to look at the list and the answer pops into our head. So imagine a very long list of numbers. Gosh, it's been a good long time ago. When I very first started teaching, I remember that there was a classroom that I was teaching in, and there was, gosh, you'll have to Google this so you can see what it is. I guess it's such an old, antiquated term, but there was a phone book. All right, there was a phone book sitting on a desk somewhere. And I haven't seen a phone book of any kind in quite a few years. The white pages disappeared, but then we still had the yellow pages for a while, but I haven't seen those in, 4 or 5 years now, it seems like. But many years ago, we had a phone book. And so I, picked it up and told students to imagine if they had a little task assigned to them this would be pretty bizarre, oh my gosh, pretty boring. But imagine it was your job to find the, quote, largest phone number in the phone book. Right, ignoring the dash in between, if you will, and we'll just count the 7-digit numbers or whatever. So you're just comparing all of the phone numbers in the 806 area code because for some bizarre reason you're trying to find the largest phone number. But anyway, so you can imagine a phone book that's page after page after page of numbers, and well, the old technique that you used here to find the largest number in a list of 5 numbers, all of a sudden, well, it doesn't work. I can't just glance at the phone book and have the largest number pop into my head. So now it kind of forces you to think of it in a more methodical way, you know, step by step way, you know. And so if I'm looking for the largest number in a phone book, you know, you guys tell me, just, you know, in a sentence or two, what do I need to do to find the largest number in the phone book? Bruce?
Start with the first number, and then if the next one is larger, you replace it with that one, and then just go.
Yeah, now, you know, you're talking about replacing, you know, so you're off to a good start there. You know, hey, so let's start at the first number and look at it. And, you know, that word replace that you use, you know, depending on what we're doing, and actually our first lab in PF2, we might actually be wanting to reorder a list of numbers in an array, and then we might be swapping elements or doing something like that. And so when we use the word replace, it kind of made me think of that, you know. Now if we're looking at a phone number, well, excuse me, a phone book, if we're looking at a phone book, I can't reorder the numbers in the phone book. They're kind of stuck as they are, you know, but I would be, you know, perhaps what I'm replacing, instead of replacing one number with another number in the phone book itself, maybe I have a little piece of scratch paper over to the side, and I'm comparing the numbers in the phone book to this number I have on a piece of paper over to the side, right? So does that sound like a reasonable step then, based on what a good suggestion you've made there, Bruce? So yeah, we're going to start at the first number, and we're going to be comparing the numbers that we encounter one by one by one by one. And then the question is, what do we compare them to? And we've kind of already answered that. We recognize, oh yeah, I need some scratch paper here somewhere. And over to the side, I'm going to keep track of the largest number that I've found so far. Because you can well imagine, man, wouldn't it be a boring task? If you're supposed to find the largest phone number in the phone book, it could take you, I don't know, all day, a couple of days, or something else like that. And certainly it would be the case. It's kind of like we talked about, I think it was in this class, if I remember, I was talking about memorizing digits of pi, and then having to come back and recite them. And you'd have to stop every once in a while to take a bathroom break, a lunch break, or whatever. Kind of the same thing here. All right, I'm looking for the phone book and updating, but I might have to stop and come back and so on. So I don't want to just have memorized the largest number I've seen so far. I probably want to write it down, because a 7-digit number, I might get them all crossways or whatever if I haven't done that. So I'm going to have my giant list of numbers. All right, so let's see here. So I got this giant list of phone numbers in the phone book. And then somewhere over here, I'm going on a piece of scratch paper. So here's my phone book entries, and they go on basically forever, it seems like. But I'm going to have to then also, on a piece of scratch paper, keep track of the largest number that I have found so far. All right. And so a couple of questions. You know, one is, what do I initialize? What initial value do I give to this variable? I'm going to need to declare a variable in my program called largest, thinking ahead. So what value do I want to assign to this variable? Because if I have a line of code that says, let's compare this array element, so assuming they eventually make their way into an array, you know, in our program. If I'm comparing this array element to this variable, my condition is going to be something along the lines of, if AR sub I is less than or greater than or whatever, largest. So I'm making a comparison to largest. Well, the old compiler, you know how that picky Java compiler is. If you haven't initialized largest to some value, the compiler is going to say that variable might not have been initialized and it won't even compile your program. So you're going to have to assign it some value. And the question is, you know, what value? Now, if we're talking about phone numbers, or if we're talking about these numbers up here, well, these numbers here, we notice that they're all positive. And phone numbers, again, we'll just delete the little dash in between. That's not a subtraction operator. It's just a little placeholder, if you will. So phone numbers also, I've never seen a negative phone number. So it would be reasonable, perhaps, to initialize largest with a 0. And then, like, even right here, so let's say that these, let's say that the first set of phone numbers are 5. That's a short phone number, I guess. You live in a real small town. All right, you got a small little town there. Anyway, so yeah, my phone number, you know, back in the day, that was the case. People had shorter phone numbers because there were fewer people that had phones, you know. But anyway, so let's just assume that these are the numbers that we're looking at. All right, so 5. I'm going to compare 5 to largest. Oh, okay. Well, 5 is larger than largest, so I update largest. Now I compare the 2 to largest. Well, the 2's not bigger than largest, so I don't have to do anything. I compare the 7 to largest. Hey, the 7 is larger, is greater than largest, so I update largest and go on. And then I compare the 3 to largest. No, it's not bigger. I compare the 4 to largest. No, it's not bigger. And then anyway, when I finally get to right here to the end of the list, once I have gone through all of the numbers in my array, then largest gets kind of promoted, if you will. As we're working our way through, this variable is used to store the largest number that we have found so far. But when we get to the end of the list, ta-da! This is the largest number in the entire list, in the entire array. And so, hey, initializing largest to 0 seems to have worked. But what? So this is going to be an array of integers. And, in lab 4, of course, we know what those integers are because, well, where's the darn thing here? And we know what those integers are. They're given right here. But, we would like to write our program so that it works for any number of different integers, not just these, that was in our testing rules, of course, And, hey, a good programmer is going to write their program not just to work for this particular set of data. So here's a set of 5 numbers, and we've got this little solution in mind. We initialize largest to 0, and then we go through and we compare all of the elements in the list, in the array, to largest, and we update largest as we go. But what if we have this? Is that a perfectly valid list of integers? It certainly is. All right, so let's try this out. I compare -5 to largest. Is -5 greater than 0? No. Is -2 greater than 0? No. No, no, and no. All right. So we get to the end of the list. Ta-da! The largest number in the array was 0. Oh, hang on a second. 0 wasn't actually even in the array. So this is, we put question marks there earlier, and how you initialize largest, depending on what assumptions you make about the data, it can be kind of a trivial thing. Stick a 0 in it. I mean, that's kind of our go-to value to assign an integer to satisfy the darn compiler when it complains about a variable might not have been initialized. As often as not, stick a 0 on it, it'll probably be fine. But we recognize that, oh yeah, with this set of data, initializing largest to 0 ends up giving us a bogus result then when we go through our little algorithm of doing our comparisons to all these numbers. So when you study these things, we recognize, okay, if I'm looking for the largest number in a list of numbers, I should initialize largest with a large negative number. I'd be tempted to call it a small number, but anyway, it's actually a large negative number. So we'll come over here and get rid of this. And well, then also there's questions about, well, are we comparing bytes or shorts or ints or longs or whatever to do the best possible job of initializing this variable? And we kind of would like to know, well, what is the largest possible negative number? But, we remember perhaps that, oh yes, with bytes, there's 256 total, so we have 128 negative numbers and 128 non-negative numbers. So, negative 128 would be a good number if we're working with bytes. And a short is 64K, half of those are negative, so approximately negative 32,000 would be a good number for to initialize largest if we're dealing with shorts. Our go-to integer is going to be an int. That's 4.3 billion. So somewhere approximately equal to negative 2.1 billion would be a good value to initialize largest to. And the truth is there's a class called math, and it does have, I think it's the math class if I remember correctly. Anyway, it has defined some variables to represent the actual largest negative number that you can store in a 32-bit int and in a 64-bit int and so on, to save you the trouble kind of digging that on your own. I don't know. I don't remember for sure if that was the math class or the integer class or maybe both. I don't know. But the truth is, well, that's all well and good, but if we were to assign largest to be the largest possible negative number that will fit in a 32-bit int, and then later on we come along and we decide, we're going to really work with some big numbers here and we want to change this to a 64-bit int, to a long. But if I leave this initialized with the largest possible negative number that can fit into a 32-bit integer, but now I've changed the program where it's dealing with 64-bit integers, now this initialization here leaves some room for errors then again. All right? So even this would be better than 0, but it still kind of leaves us open to having some problems later on, again, if we were to change the size of the numbers that we're working with, trying to change the size of the elements in the array over here then. So anyway, so let's just kind of restate. If we're looking for the largest number in a list of numbers, we can initialize largest to the largest possible negative number. But sometimes, hint, hint, when we come back here in PF2, and we're searching for the smallest number in a list. Well, it's important that you recognize, okay, if we're searching for the smallest number in a list, then we need to initialize our variable called smallest to the largest positive number. So you can remember that, or otherwise just kind of think it through and come up with some sample data and so on and make sure it works. And again, you kind of just, ultimately the rule is to go the opposite direction. Initialize largest with the largest negative number. Initialize smallest with the largest positive number. All right? But we can even do away with that. So, in fact, I'll get rid of my negative signs here also then, I guess. All right. So what would be a better value to initialize largest with that would actually work whether we're looking for the largest number or the smallest number without having to think through that little logic problem there, and that we might get wrong and end up with our program not working correctly. So instead of having to figure that out, make sure pick either a large negative number or a large positive number. Can anybody think of another alternative on how to initialize largest? What's that now? If you're thinking of some max or min number, we kind of talked about that. Yeah, I think it's the math class or maybe the integer class does give you the largest positive integer in 32-bit ints and the largest negative integer and so on. So one of those would work, but we'd have to make sure we pick the right one. Do we want the largest positive integer or the largest negative integer? And I'd like to avoid that problem entirely of having to figure out which one of those directions do I want to go. So that would be beneficial, but there's an even better way that we might initialize this variable largest. It's going to be one of those, oh yeah, of course. All right, we got a suggestion back there, Claire?
An absolute value?
That's a reasonable guess, And I'll tell you that the number is the value that we should initialize largest with is actually on the screen. Oh, hey, there we go. Very, very good. That's exactly right, Zach. Yeah. How about one of the elements in the array? So really any of the elements in the array would be perfectly fine. 7's a good one. Yeah, that's right. Now, of course, you kind of cheated the whole process there. You found the largest number. We'll initialize largest to it. And if we did that, would it still work? Yeah. We initialize largest to 7. Well, the 5's not bigger. The 2's not bigger. The 7's not bigger. The 3's not bigger. The 4's not. Ta-da! We end the loop. And we initialized largest with 7. And largest is still 7. So that would work. So actually, any of the numbers in this list, any of the numbers in the phone book or whatever, we could pick any of them. But syntactically, there's one of these elements that I kind of prefer. So like this array over here, let's say phone numbers. Well, I don't know, there might be 100,000 phone numbers of residences, for instance, or we've got 300,000 people, but including households. Of course, actually, probably every darn person, just about, unless you're a really young kid, is going to have their own. So we'll say that there's 200,000 phone numbers in the local area, in Amarillo. 200,000 numbers. And we could initialize largest with any of those, So the array would have 200,000 elements in it. This array here only has 5 elements in it. So, with the phone book, I could say, well, I'm going to flip a coin or throw a dart at a board or whatever, and I'm going to initialize largest with the 100th element, kind of a random thing. Oh, the 100th element in the array, that's what I'm going to use to initialize largest. Well, what if your array doesn't have 100 elements? What if your array doesn't have 5 elements? What if your array doesn't have 4 elements? Well, our array should have at least, what's the minimum number of elements an array might have in it? What would your guess be? Two's a reasonable guess. You're real close. Even better. There you go. So yeah, you can, in Java, you can sit down and declare yourself an array, reference variable, instantiate it with equals new, int, square bracket, 1. That'd be kind of bizarre, having an array with one element, because it's just kind of a pain in the neck to get to it, because you have to specify the array name in square brackets and then its index, which is a 0. But it would work. You could have an array with one element. But so anyway, that was a good little exercise to think about. Oh, okay, well, since all arrays have at least one element, in other words, all arrays have an element at index 0. Okay, so we can make our assignment to largest, very generic. It's not dependent on the array being a certain size or whatever. We recognize that all arrays have at least one element. All arrays do have an element at index 0. So I'm going to say that we ought to just initialize largest by copying this element here down. Okay. Now to be clear, if this was our array here, I don't want to then say largest equals, in my code, I don't want to say largest equals 5. I don't want to say largest equals 5 because, well, sometimes, boys and girls, the first array element is not a 5. Okay, so sometimes the first array element is not a 5. So I'm kind of giving a hint here. When you're writing the code and you're going to need to initialize largest, well, for this particular set of data, yeah, 5 is the first element, so the 5 will get copied down here. But the syntax is not largest equal sign 5. Instead, largest equals, and this is whatever our array name is, sub 0. Does that make sense? So we're using array indexes, our array name, and the index of 0 to copy this element into our largest variable. Okay? And now we're off to the races. And the good news is, whether we're looking for the largest element or the smallest element, it doesn't matter. Just assigning largest or smallest with the very first element is perfectly fine. Just like Atak said that, hey, if we were to initialize largest with a 7, it ends up being the largest. Hey, well, that's perfectly fine, Or if, like here, if you initialize largest with the 5, well, it's not the largest, but it all comes out in the wash, because eventually, as we work our way through, we'll compare largest to all of the elements in the array, updating largest as needed. And when we finish the loop, when we finish looping through the array, ta-da, largest will have the largest element of all. So that looks perfectly fine. Hey, so one thing related to that, though. So normally, hint, hint, for I equals 0, semicolon, yada, yada, yada. Most of the time, especially if we're working with arrays, most of the time, when we initialize our looping variable, I'll do it this way, most of the time, we do this. But the for loop is going to be used to generate the indexes of these elements that I'm comparing to largest. So I equals 0. That's, if I'm wanting to calculate the sum of the elements, I'd initialize my looping variable to 0. If I wanted to print all of the elements, I'd assign my looping variable to 0, because I normally want to go through all of the elements, starting at the very first one. But my question is, based on how we decided we were going to initialize largest, do I really need to compare the first element in the array to largest? When we start out, largest gets assigned from the first element in the array. So when we compare largest to the first element in the array, guess what? They're always going to be equal, right? Because that's how we initialize largest. So we can put a little bitty performance increase in our program, and also, more than anything, it just shows that we really thoroughly understand what's going on here. Since I'm initializing largest with my first array element, I don't need my for loop to compare largest to the first array element, because that's always going to be equal. So since this looping variable I is used to generate those indexes, what is the index of the first element I want to compare largest to? What is the index of our array element that we want to compare largest to? Close. So up over here. Let's do this. All right. So these are the indexes in an array. Good grief. Okay, so there's that. So largest gets, and if our array name, all right, so if this is our array, AR, and we'll draw a little box around it here. Okay, so here's my array, and there's my indexes down below, and so on. Largest is going to get initialized with AR sub 0. So what is the index of the first element I want to actually compare largest to? What was that again, Zach? 1. There you go. Okay. So we can get again, it's not much of a performance bump. It's teeny tiny, you know, it's infinitesimally small. But if nothing else, it shows that you understand what's going on here. Since we're initializing largest with AR sub 0, I don't need to compare largest to AR sub 0. And in fact, the first element that I want to compare largest against is this guy here, which resides at index 1. And hint, hint, that should then be reflected in this for loop, how you initialize your looping variable. And of course, the other details, your loop entry condition, well, I want to loop through all of the elements, so it's going to be as long as I is less than AR.length, for instance, then, okay. And then our updater, kind of just like you would normally expect, probably just I++ will be all that we need there. And so this is looking pretty good. So we've initialized largest, and now we started writing our for loop. And inside of here then, we're going to have, oh, what the heck, we'll put a little curly brace, and I'm going to say if array element is larger than largest. All right, so here's an if statement inside here. And then what I'm going to do, I'm going to make an assignment to largest. Okay. See what we've done there? So again, I'm writing kind of pseudo code here. I want to leave the actual code to you. But I've got a loop that's going to allow me to loop through all of the elements, well, except for the first one. This loop is going to allow me to loop through all of the elements starting at the second element. And then inside of there, I've just got a single if statement. And that if statement is going to compare the element in the array at index I with largest. And if the element in the array at index I is greater than largest, then I need to update largest. I found a new bigger one. All right, you know, just as we work our way through, largest gets initialized with 5, and then I go into the loop. The loop starts me out at index 1, and I'm comparing the 2 to the 5. Well, the 2 is not bigger, so I do nothing. And then I loop back through again. Now my looping variable is 2, which allows me to index element. This is the 7. Is 7 greater than largest? It is. So I update largest, and I keep chugging along here and then. All right, so this gets updated to a 7, and I keep working my way across, and I'm updating largest as I go. And so this looks pretty good. You know, I'm going to leave one little gap here, and then a closed curly brace and a closed curly brace. I've left room for one more little statement here, which is kind of, it's reflected in the instructions for the problem also, but you can well imagine. So that was first day on the job, and your bizarre boss gives you the phone book and tells you to find the largest number in the phone book. So you have your little scratch sheet over to the side where you're keeping track of the largest number I've found so far, and you're comparing each number to the largest number you've seen so far, page after page after agonizing page. And you finally get to the end, and you then come in and tell the boss at the end of your 5-day marathon or whatever, I found the largest number in the phone book, and here it is. There's actually somebody whose phone number is 999-9987 or whatever. All right. And then the boss says, okay, that's good. Hey, now tell me, what page in the phone book was that phone number on? And if what you've done is exactly what we've described, you have this little scratch paper, and you've kept track of the largest numbers as you found them. And somewhere on the entire phone book, you found this phone number, 999-9987. But then when you, quote, finish the project and you tell the boss what you found, and he asks you what page that phone number was found on, your answer is probably, well, heck, I don't know. You didn't tell me to make a note of the page, for instance. And then what do you got to do? Go back and look through the whole stinking phone book looking for that phone number, would be what would be required. But, or, if he wanted you to find the largest number in an array, and then after we find it, we want to do something with it. We want to modify it in some way. Well, if we need to do something with that piece of data, if we want to modify that piece of data, and that data resides somewhere in an array, what are we going to need? That element's index. So, yeah, our picture's kind of incomplete. In addition to keeping track of the largest value that we found in the array so far, if at the end of the day we want to find that largest number and we're going to reassign it, we're going to zero it out or whatever, you know, we also need to know its index. So it's the index of the largest. You know, every once in a while I'll be lazy and I have before just written this as largest index. Well, it's not the largest index. The largest index is the very last one, right? That's the largest index, like in this array up here. Oh, the largest index is a 4. Well, no, that's not what we're talking about. We want the index of the largest element. Okay, so this is a better variable name. Index of largest element. So I have 2 variables on my scratch sheet now when I do this. Largest keeps track of the largest value I've found so far. Index of largest keeps track of at what index did I find that largest value. So going back to the drawing board here a little bit, we'll do it this way here. And so let me go ahead and kind of, all right, get rid of this. Okay, move this over just a skosh. All right, so let's say then, all right, we're going to kind of redo this problem. So we're going to reinitialize largest, and largest is going to get initialized with the first array element. It's the value of the first array element, which is going to be a 5. Do I need to initialize index of largest? Well, you know, what if I had this? What if I had this? What if the first number was a 15? So I initialize largest to 15. Is 2 greater than 15? No. Is 7 greater than 15? No. Is 3 greater than 15? No. Is 4 greater than 15? No. So I finished the loop. Ta-da! Largest, the largest element in the array is a 15. But, I've yet to make an assignment to its index. So I don't know where that resides. So it's not likely that the first element is going to be the largest element, but if it is, we need to initialize index of largest also. So there's the bonus question. If we initialize largest to, for instance, AR sub 0, I wonder what we should initialize index of largest to. What is the index of the element that resides at index 0? Well, that was a tricky question, wasn't it? Okay. Yeah, I guess I should have said, what is the index of the first element in the array? 0. Very good. All right. Thanks for helping me out there. Yeah, so yes, to be clear, before the loop. So let's do this. Initialize largest and index of largest. Okay? So we're going to initialize both of those before the loop. And then as we work our way through the data, so largest is a 5 and index of largest is a 0 and so on. And then I compare the 2 to largest. The 2 is not bigger than largest. And then I compare the 7 to largest. Oh yeah. So when I compare the 7 to largest, I need to update largest, and I also need to update the index of largest. The index of largest. So down here, when I find an element that is larger than largest, yes, I need to update largest. I also need to update index of largest. So let's talk about that. So, updating largest, it'd just be largest equals AR sub I, for instance. AR sub I. But what are we going to assign to the index of the largest? Like in our data here, all right, we initialized largest with a 5. We started our comparisons with the 2 that resides at index 1, and we're working our way across. Well, the 2 is not greater than the 5, so we do nothing. The 7 is greater than the 5, so we update largest with the array element. So the array element, AR sub I, for instance. But then we need to update index of largest. So, well, we just went down here. Oh, the index of where the 7 resides, that resides at 2. So we just assigned it a 2 here. But when we write the code, this first statement, we're making an assignment to largest from the array element that resides at index I, right? So, you know, the array element that resides at index I. And now we need to take the index of that element. So I'll ask that same question we asked a minute ago. What's the index of the element that resides at index I? I. So when we're making the assignment to index of largest, it's just I. Does that make sense? You know, I is what's allowing us to loop across our array and access the second element and the third element and the fourth element and so on. And at any given point in time, I has the index of the element that we're comparing to largest. So I is the index that we're going to go to retrieve the largest value and assign it into the largest variable. And I is the index of that element. And when we're making an assignment to index of largest, we assign it literally just I, because I has the appropriate value at that point in time as we're working our way across. Just equals I, just as simple as that. It's kind of too simple. It's too simple, and it's real tempting for students to try to assume things are more complicated than that. But you know, let's tell you what let's do here real quick, just for the heck of it. Let's move this down, you know, to here, and then let's just kind of work through here real quick. So let's do this and this. And tell you what, let me make some more room here also. So, you know, another way to kind of picture this is, all right. So when we write this loop, here's another way to think about this. When we rewrite the loop, we're going to initialize I to 0. Oh, excuse me, I to 1. I said that wrong. I guess I glanced down here. We're going to initialize I to 1 so that it can index the second element. And then so the first time I go through the loop, I is 1, and it's indexing the 2. And then the next time through the loop, I is 2, and it's indexing the 7. And the next time through the loop, I is, that's not good, 3, and allowing us to index the data value of 3 then also. But anyway, so at any given point, like right here, when we have moved I from here, no, 2's not bigger than largest, then we move I down here, aha! AR sub I, that's this guy here, is greater than largest, which is a 5. So we make an assignment from AR sub I to largest. But when we update index of largest, well, where is that index stored? It's good old variable I. At that point in time, when we're comparing the 7 to largest, I has a value of 2. And we need to get that 2 in index of largest, and we do that by simply assigning index of largest equals I. Does that make sense? All right, you guys. Could that be it? I think that it is. I think that it is. So let's look at the assignment here then. Back over here we go. So problem number 12. Find the largest array element in the my array. Again, you're going to initialize my array here just by, I'd suggest copy and paste this into an array initializer. And it tells you, save the largest value in a variable named largest, okay, largest num, and then save the index of the largest element in index largest num. And then after you exit the loop, print these two values out. All right. And I would suggest when you write this program then, you know, ultimately, this is the data that I want your lab to have when you submit your program, you know, the final time and leave it there for me to grade. But this would be a good little exercise for you to do, is we recognize that, you know, we're initializing largest with the first array element and then the index of the first array element and so on. And if it turned out, if instead of 11, if this was a 111, this would actually be the largest element. We'd want to make sure that our program still works correctly when the largest element is the first one, or if it's any of these here in the middle. It's probably not going to be any different, but you might also be curious about, well, what if the largest element is at the very end? Is the program still going to work then? So to kind of get you thinking about how to be a good tester of your own code, which is a necessary skill in PF2, and oh my goodness, in PF3, I would encourage you, after you've written problem number 12, where it finds the largest number and the index of the largest number and prints those out, temporarily change this number so that it's the largest, and run your program and make sure it finds whatever number that is, 111 for instance, at index 0. And then put the, well, the largest number is going to be this guy here right in the middle. You know, you probably would have already tested it for that. But then just to be curious, make sure your program works. Again, testing these boundary conditions, kind of like we did with the program that turned a number grade into a letter grade. Hey, make sure your program works when the largest number is at the first, somewhere in the middle, and also at the last. So temporarily, just those two changes, plus of course we recognize here this fairly short list, the largest number in the array is this guy at whatever index that is, 6 or 7 or something like that, you know. But I would encourage you to test your program when the largest number is at the first or the end also. But then change it back to when you're ready to turn the thing in. I think that's it. I think that's it. Can you guys think of questions on problem number 12? Yes?
When you declare your largest, like a variable, you would say int largest. Right?
That's correct. Yeah, good question. That's right. So look, back to our picture over here, the sloppy, horrible mess that it is. Yeah, so we have an array. Of course, in this picture here, our array's reference variable is just called AR. But anyway, in your program, you're going to have, my array is the name of your array reference variable. But yes, to be clear, largest and index of largest are just ints. So it will just be int largest, int index of largest. That's right. And then as we've kind of sloppily thrown in here, oh yeah, don't forget, before your loop, I said initialize, but I could have said declare and initialize, just those. Declare and initialize the two integer variables, largest and index of largest. And then down here, of course, just to make our pseudocode a little more complete, what the heck. So before the loop, we will declare and initialize largest and index of largest. And then our loop will run through all of the elements, starting at the second one, and do our comparisons and update largest and index of largest as we go. And then here, after the loop, is where we'll print largest, or largest num, I think the assignment says, an index of largest. Not too big of a deal. But again, I'm begging you guys, especially for the bulk of you, which are going to be coming back either in the summer or the fall to take PF2, this problem number 12 is really kind of a first step into the kind of problems that you'll tackle in PF2. And so if you're just decide because, well, you got final exams this week in your 8-week classes, so you're just going to take some shortcut or whatever and kind of blow off problem number 12, and not really learn that lesson, you will then find yourself entering into a more difficult course, PF2, underprepared, because the one problem that is most critical of everything in PF1 in terms of preparing you for the rigors of PF2, where we're working with arrays and loops and if statements, it's problem number 12 from lab 4. So of all of the labs all of the problems of all of the labs in PF1 that you want to put your best effort into and make sure you really understand it and that you can come up with a solution on your own just based on this little pseudocode that we talked about. It's this problem here. Don't shortchange yourself or you'll be behind from day 1 in PF2 then. Questions on the lab 4? Questions on the midterm? Hey, one other thing. So there's one other component that I'm glad I thought to mention, that our class meets for 2 hours and 15 minutes. Usually, I don't give the full 2 hours and 15 minutes. That's a long time to go, especially with our no bathroom break official rule, at least. I don't know about you guys, but about the 2 hour mark is about the limit where I'm comfortable. And so the one other little thing, just so you know, and to be honest, I haven't written your test just yet. I'll do that over the break. But depending on the quote difficulty, relative difficulty of the problem or problems that I give you, I will often shorten the test time a little bit. I want to give you plenty of time. And I'm a pretty good guess as to how long it should take students to tackle any given problem. And I'll give that amount of time plus some more. I absolutely will. But what I have found is I can give a problem that might stump a particular student, and you give them another hour and a half, and as often as not, the answer just, if it didn't come to them within the first 30 minutes, an hour later, they're still not going to be able to get it, So do expect that I will give you certainly no more than 2 hours. And if the problem is a little easier than some that I might have given in the past, it could be as short as an hour and a half, somewhere between an hour and a half and 2 hours in for test time on Monday when we return. All right. Going once, going twice. Oh yeah, we'll need to pick a due date, and just for the heck of it, I'll stop the video, then we'll announce that, and I'll post it on Blackboard then. So let's do that very thing.